this is a review for Unit 5 test, and I may break it into two parts, depending on where I get and where I'm interrupted. Okay, given the rational function in the form f of x equals p of x over q of x, how do you find the vertical asymptotes? The vertical asymptotes, those are the ones where you set you can say it like this. There's more than one way to say it that I would find acceptable. Set q of x, the denominator, equal to 0 and solve for x. For x, okay, or you could say find the zeros of the denominator. Yeah, absolutely. Factor the denominator, set it to 0 and solve, sure. 2, horizontal or oblique asymptotes. You don't have oblique, I think I took that off anyway, right? Horizontal asymptotes, you compare degree of the numerator to the denominator. That's important. That's how you start off. Compare the degree of p of x and q of x. Okay. Now I let you say top heavy and bottom heavy in equal weight. If top heavy, which you better know means the degree of the numerator is higher than the degree of the denominator, okay, then no vertical asymptote, no HA. You can abbreviate that. If bottom heavy, the horizontal asymptote, or you can just say y equals 0. And if equal weight, y equals lead coefficient over lead coefficient. Okay. 3, the x-intercepts. There's two things you could say about that. Okay, so if it's in y equals a over x minus h plus k form, then let y equal 0. I mean, both of them you can do this. This is one way to just say, you can say let y equal 0 and solve for x. I don't know why I say and solve for x, which is the same as if it's in the p of x over q of x form, then you are finding the zeros of the numerator. Okay? That would be let y equals 0 if you're doing it in that form. And then I think some of you look at it like if it's in the form p of x over q of x, zeros of the numerator, or zeros of p of x. It always works if you let y equals 0, though, because even if you had 0 equals p of x over q of x, what would drop out if you do cross products? Yep, the p of x, the q of x would drop out, and you would have p of x equals 0. See what I'm saying? So you could solve for it that way. Whole or discontinuity, there's a whole or point discontinuity when there's a common factor in the numerator and denominator. Well, when there is a common factor involved with x, it has to have an x, guys, right? If it's just a 2, that's not going to cut it. So if there's a common factor, with x in both p of x and q of x. Was it prefaced in the beginning, guys, that it was in p of x and q of x form? I forgot. These questions that were only if they're p of x or q of x. Oh, so I didn't have to put this in there right here. You only need to, you could say let y equals 0 though and solve for x, or zeros of p of x. See this one right here? I just wanted to remind you in case there's one on there and you got to graph that. that if you needed to find the x-intercepts, that's the kind you got to put in 0 for y and solve. Okay? So that was not really part of the question since it said p of x over q of x. No. You get to use your calculators. All right, for each equation, identify the x-intercepts. Did we go over this one? This one's in that form, y equals a over x minus h plus k, though. All right, so if you want to find the x-intercepts, then we got to put in 0 for y. And if you solve this, you would add 6. You would need to cross product, so you'd have 6x plus 12 equals 6. You would subtract 12 from both sides, get negative 6, divide by 6, and you get negative 1. So negative 1, 0 is the x-intercept. I mean, you can find it on the graphing calculator probably, but... All right, and then B says write the equations of all vertical asymptotes. That would be x equals negative 2. Horizontal asymptotes would be y equals negative 6. So x equals negative 2 is here. Y equals negative 6 down here. Okay, and then next you would need to find points that are in each section. So you need to check values to the left of the vertical asymptote. So I make a t-chart, or you can actually go in your grapher if you want. But I'm going to plug in negative 3. I'd like to see what points you're trying to plot, and they better be clearly labeled or visible on your graph. Okay, so I put in a negative 3. That would give me a negative 1 in the denominator, and 6 divided by negative 1 would be negative 6 minus 6 is negative 12. So negative 3, negative 12 is a point. You might want to put in a couple more, maybe put in negative 4 or negative 6. No, that'd be a key number. Negative 8 would be nice. If I put in negative 8, I'd get a negative 6 in the denominator, which would give me negative 1 minus 6. That's negative 7. So that gives me a good idea of the shape. And I didn't say you had to have these, but it shouldn't be, you know, you should not be showing this coming close in here. You ought to figure out that it's not, all right? So you should check it. So I don't want to see your graph going like this when it's not what it looks like. Follow me? You get a couple of points. All right, so anyway, this section over here, I've already got the x-intercept, but maybe I ought to put in something like the y-intercept. I like to see y-intercepts shown. It might even ask you for a y-intercept possibly. If you put 0 in here, you'd have 6 divided by 2. 3 minus 6 would be negative 3. Okay, and then maybe you could go ahead and sketch it. You can tell basically what it's doing. All right, the domain's all reals except x can't equal negative 2. And the range is all reals. Y can't equal negative 6. See if we can get through another one before I pause. Number 6, you've got the denominator. If we want to identify all the x-intercepts, that's what makes the numerator 0. So 9x plus 1 equals 0 would give you 9x equals negative 1. And then you divide by 9, negative 1/9. Negative 1/9 0 would be your x-intercept. It's just very, very tiny. You can't really plot that clearly, but that's where it is. Okay, if you want part B, write the equations of all the vertical asymptotes. That would be x equals 2/3, 0 of the denominator. 2/3 would be, oh my gosh, in here. That was one I'd rather pull up. I've done it before. See the equations of the horizontal asymptotes. This would be y equals 3 because it's equal weight, numerator and denominator. 9 over 3 is 3. Okay, I would make a t-chart, plug in 0 for x because that's to the left. If you plug in 0 for x, you're going to get negative 1/2. All right, so this is going to do this. And then I would put in 2. 2 would be 18 over 6. 18 plus 1 over 6 minus 2. That's going to be 17 over 4. So that's like 4.25. Okay. Did I do something wrong? Oh, sorry, 19 over 4. Hello, Heimer. 18 plus 1 is 19. All right, so that was how big? 4.75 then, right? Okay, so it's almost 5. 2, getting close to 5. Oh, almost 5. I went too high. Trying to hurry here. 1 second. Okay, and so in this section, just sketch that piece. Okay, domains all reals except x can't equal 2/3. And the range is, you can wait for me, y can't equal 3. Okay, that was this one. Number 6. Number 7. I already have it graphed, and that we had already done this particular one yesterday, so that's why I pulled that up. I'm not going to re-explain this one. I'm just going to sit here for a second and let you see the answers. Does anybody need me to say anything else about this in this? Okay. Again, I showed the t-chart. I showed the values that I need you to plug in to the left and right of the vertical asymptotes, and you certainly can look on your graphing calculator to make sure you know what the shape was supposed to be in here. Okay. All right, we also went over number 8 and determined the hole in the graph by factoring and finding a common factor of x minus 3 in both the numerator and the denominator. Then once we found the value of 3, we reduced down the equation to y equals x minus 1, and we plugged in 3 into that equation to find out the exact location of that hole, which was at 3, 2. Okay, anyone need any more information about this problem? All right, Rory wants to know if the following function has a removable discontinuity, and it does. How? Because it says A, figure out where or whether or not it does. A is a yes. There is a common factor of x minus 4 for p of x and q of x. Whatever, I don't have to write all that. That's good enough. B, describe what you do to find if there is a removable discontinuity. It was factor p of x and q of x, or let's say, since it didn't say anything about p of x and q of x, let's just say it in more of normal terms, that factor the numerator. My pen's stuck, excuse me. Factor the numerator and denominator. I already did this once, didn't I? Okay, so if there's a common factor, x or x minus a, then there is a hole. Okay. Good enough? What is the domain of this function? You factor the denominator. And you factor the numerator if possible. It's not factorable. The domain would be everything, all reals except x can't equal -7 or 7. Okay, find all the asymptotes and holes. I think we went over this one yesterday. We factored the numerator. We found there to be a factor of x in common, which would be setting x to 0, and then we plugged that back into what was left as the reduced form, and we got 0. Do we have any questions about this? The asymptotes are -3 and 3 for the verticals, and it's equal weight top and bottom, so y equals 4 for the horizontal. Any more questions on this one? Okay, we looked at these already together. Do we want to discuss these any further? Either of them? No? I suggested that maybe since some people were having a little trouble keeping control of things that they crossed out all like back and forth, that you could just go ahead and multiply across, and then simplify. Yep. Uh-huh. That doesn't matter as long as you end up with the right answer. Okay? This is what it needs to look like when you're done. Okay? And like I said, I did a whole bunch of crossing out and stuff after that on these. Do we want to start any of these over again? Jade, were you raising your hand? So we did these yesterday, but I can start over if you want me to. All right, so this should be your end result, and if you need to stare at this a while, if you're watching the video, then you could go ahead and do so. What's that? Yep, you can pause it and check it out step by step, right? This would be redlined here because all I was doing here, why I have this crossed out, is I continued factoring it. Okay, we went through these as well. Yeah, we did do a lot yesterday. You guys asked me quite a bit in this class yesterday. So my poor second hour, if they're having to watch this, I don't know. We went over these today with them though. No questions then on these? All right, going forward. Perform the indicated operation and simplify completely. Now this is doing subtraction, and we really didn't do too hot with this on the first 9192 quiz. This was one of the topics that was probably the most challenging. If the denominators match, then we just do stuff with the numerators, which is subtract them. And we leave the denominator in the answer, unless it can be simplified further. So what I look at is now that I have my correct numerator, I want to factor it. And that would be factoring out a 6x, which would leave me with x minus 2. And oopsie-day, we got an x minus 2 in the denominator, so we get to cancel that out now. And the final answer is just 6x. Nope, this isn't a graph. No holes when you're not graphing. It's not a function, it's not written as a function. And it doesn't ask us to graph, so no. You can tell me though what the exclusions are in the domain. X can't equal, no, I mean, this just tells you x can't equal 2, but there's no solution to this one in the first place because it doesn't have an equal sign. All right, this has different denominators. So the LCD is both of them put together, x plus 6 times x minus 6. So the first fraction we need to multiply by x minus 6. The second one by x plus 6. Then all of those numerators are now going to get simplified and combined. The denominator will be x plus 6 times x minus 6. Do not start crossing stuff out. You can't do that. You just did it to them. You don't want to cross out anything. All right, distribute. You get 4x minus 24 minus 2x minus 12. That will be over x plus 6 times x minus 6. 4x minus 2x is 2x. Minus 24 minus 12 be minus 36. And then you have your denominator x plus 6 times x minus 6. Now, if you were to factor out a 2 from the numerator, would it do anything to help you reduce? No, so we can just leave it at this. Does anybody still need that? Okay. Number 20, put a 1 under the 5 if you want to. The denominator is y times 1. So you don't have to do anything to the first fraction. But the second one, you're going to multiply by y, top and bottom, which gives you 3x minus 5y in your numerator. And that's done. Number 21, we need to factor the first fraction, which would be x minus 9 times x plus 4. The second fraction is missing the x minus 9, so our common denominator is x minus 9 times x plus 4, which means we're going to have to multiply 18x by nothing, okay, because it's already got the whole denominator, plus 2x times what we need to multiply the second fraction by would be what's missing in its denominator, and that's x minus 9. So you're actually doing this. You're multiplying x minus 9 times the top and the bottom of the second fraction. Okay, so when you add and they have the same common denominator, you can put together their numerators. We're going to simplify the numerator now by distributing 2x. Get 2x squared minus 18x. Oh, that's kind of convenient. The 18x's wipe out. And so I'm going to go ahead and just write 2x squared over x minus 9 times x plus 4. I skipped writing the denominator on this step right here. That's finished. You cannot cancel out an x. These are married to each other. Okay, 22, we need a common denominator. You need all of the first denominator, which is 3x. So the LCD would be 3x times x plus 6. The x attached to the 6 is not the same as the x that's being multiplied by the 3. So we need to multiply the first fraction by x plus 6, top and bottom, the second one by 3x, and then the LCD for them both would be 3x times x plus 6. Distribute in the numerator, gives you 4x plus 24 plus 6x. Still have your denominator of 3x times x plus 6. Going to finish simplifying. I've got 10x in the numerator plus 24. And then the denominator, 3x times x plus 6. If I were to factor out a 2 in the numerator, nothing would change, so I'm not going to bother. Because it wouldn't simplify any further. All right, number 23. The first denominator factors to 2x plus 1 times 2x minus 1. So the LCD would be that denominator because the second one already has a 2x plus 1 in it. All right, so we're going to multiply the second fraction by 2x minus 1, top and bottom. That's what I'm doing. This one I did 3x, x plus 6, x plus 6. That's what I did on the last one. Okay, now, I don't have to do anything to the first fraction because it already has the whole LCD. So I just rewrite that one, 5x, and I'm going to put it over the least common denominator of x plus 1 times, 2x plus 1 times 2x minus 1. So I bring the minus 2 with it, and I multiply that times 2x minus 1. You can avoid that step if you distributed right away. I've got 5x minus 4x plus 2 now. And I'm just going to finish off that numerator. Simplifying it would give me x plus 2, and in the denominator, 2x plus 1 times 2x minus 1. Pardon? 5x minus 4x is x. Okay. What? A minus 2 here? I got it. Okay, yep, you got to watch that sign between there. Okay, 20. Oh, there's another 23. These are solved problems, so you need to multiply everything by the LCD. You need an x, you need a 2, we already got the x, and you need an x plus 1. So the LCD is 2x times x plus 1. If I multiply through the first fraction by that, the x would cancel. So I'd have 2 times 7 times x plus 1. The denominator would be gone. If I multiply 6 over 2x by the whole LCD, maybe I'll show this. In here, when I did this one, I got rid of that. That's why it's 2 times 7 times x plus 1. On the right side, the 2x would cancel out, so I'd have 6 times x plus 1. And then I have a plus sign, and I've got a 3x. And what's going to cancel out would be the x plus 1. So I have to multiply 3x times 2x. Now I'm going to distribute 14 over the x and the 1. So that's 14x plus 14. Distribute on the right, 6x plus 6. Plus multiplies 3x and 2x, 6x squared. I need to set this to 0, and I'm going to rearrange it so the 6x squared is first. I'm going to subtract 14x. 6x minus 14x would give me minus 8x. I have to subtract 14. 6 minus 14 is minus 8. So this is what I've got at this point. Did a lot of algebra steps all at once. I'm going to divide everything by 2, including 0. Which would give me 0. 3x squared minus 4x minus 4. You can do that. Now you are going to factor 3x minus 4x minus 4. That's going to give me negative 6x and plus 2. Okay, so I've got 3x plus 2 times x minus 2. Okay, that gives me solutions of x is negative 2/3 and 2. Does everybody know how I got those? I just set each factor to 0 and solved it in my head. All right, now I got to double check though, back to my original problem. There were restrictions on the domain. The x couldn't equal 0. It couldn't equal negative 1. I didn't get either of those. These are 2 answers to the problem. Number 24, you can factor x squared minus 9 times as x minus 3 times x plus 3. The second fraction on the right has an x minus 3, so that's the LCD. You're going to multiply through by x minus 3 times x plus 3. So I'm just showing that I'm doing it to every part of the problem. All right, I'm going to erase, guys, this factored thing right there just to get it out of the way. And then I'm going to go after the problem. So the whole denominator cancels, of course, on the left, giving you 18. The x minus 3 cancels with the x minus 3, so you'll have 3 times x plus 3. And then 1, you got to multiply it times the whole denominator. So instead of writing x minus 3 times x plus 3, what does that actually equal? X squared minus 9. Yep, that'd be better to go ahead and multiply it out. Distribute on the right, and we get 3x plus 9 plus x squared minus 9. Well, the 9s are opposites, so that's simplifying, getting rid of those. Set it to 0. And we'll rearrange it, so x squared's first, plus 3x, and then subtract 18. Factor, this would be x plus 6 times x minus 3. And then this would give me x is negative 6 and x is 3. Now, if I go back to my original problem, what were the exclusions from the denominators? Can't equal 3 and it can't equal negative 3. Therefore, we get rid of that answer, and the only answer is negative 6. Okay. 25. Do cross products. 2x times x minus 4 equals x squared times 4 minus x. Get 2x squared minus 8x equals 4x squared minus 4. Whoopsie. Minus, I made a boo-boo there, 4x squared minus x to the third. X cubed. Okay, that's right, isn't it? Yes. All right, I just didn't do this one today. So I need to get this set to 0. So I'm going to add x cubed. I'm going to subtract 4x squared, so I have minus 2x squared. And then I got a minus 8x. Now I'm down to a trinomial, and it has a common factor. Every one of them is divisible by x. X squared minus 2x minus 8 equals 0. And then that's factorable to the x minus 4 times x plus 2. So I've got 3 answers. 0, 4, and negative 2. If I go back to the original problem and say, well, x is not allowed to be 4. So that gets rid of the middle answer there. And you have 0 and negative 2. What's the domain of this? All reals except x can't equal 7 or negative 7. Do I need to go into that one? This is x plus 7 times x minus 7. Oh. Do you have this? Okay, find the vertical, horizontal. I don't know why that's not there, but the vertical and the horizontal. This one factors on the denominator 2x. Wait, first take out a 4. Oopsie. I mean, I didn't have to, but that would be actually the best way to do it. All right, and now I can factor that to x minus 5x plus 5. Okay, so verticals are x equals 5 and x equals negative 5. Horizontal, this is bottom heavy, so y equals 0. Does this thing have a hole in its graph? Got to factor and find out. 2, 4. Denominator factors to x minus 5x plus 2. Yes, there is. Yes, there is a hole when x is negative 2. So I'm going to cancel out that negative 2 stuff, those factors, not stuff. And then I'm going to plug in negative 2 here so I can tell where that hole is. Might be a weird number. Some teachers don't make you do this part, but 3 times negative 2 minus 4 would be negative 6 minus 4, negative 10, over denominator negative 7. So that's going to be positive 10/7. Okay. What does the phrase end behavior mean? It means, what does f of x do as x approaches negative infinity and as x approaches infinity? Is f of x pointing up or down? Okay, something like that. I mean, going up or down. Up, down, or approaching something, right? Or approaching a value. Like when we get an asymptote, you know. So if you have part of your graph doing this, you got to show the correct end behavior. Means you got to show me it's pointing up, that going up to infinity there, and it's coming down, and it's actually approaching whatever that value is on this end. It's approaching to f. It's approaching f of x. Value of 2 for f of x. Right. Solve each question. Working alone, John can paint a fence in 6 hours. That means in 1 hour he can do a sixth of the job. But it's a work problem, and I know I'm going to be adding up stuff. So Sean can paint the same fence in 7 hours, so he can do a seventh of the job in 1 hour. And how long would it take them if they work together? Well, 1 over in 1 hour together they can do some amount x. So then we go and multiply through by a common denominator, which would be 6 times 7 times x. In the first part we get 7x. Second one, 7 would cancel out and you'd get 6x. And this part, 6 times 7 times x, you get 42. Then you add 13 X equals 42, and you divide by 32, and it's some decimal. Can you 3.23? And that would be in hours. And of course, if you did 0.23 times 60, that would mean a little bit more. I don't know. How many minutes is that? 13-ish? I'm not going to matter if you give me a decimal, though. Working alone, Perry can pick 40 bushels of apples in 9 hours. One day his friend Michaela helped him, and it took only 3.94 hours. How long would it take Michaela to work to do it alone? All right, he can do 1/9 of the job in 1 hour. I don't know how long it would take Michaela, but together they were able to do it in 3.94 hours. So 1 over 3.94, multiply through by 9 times 3.94 times x. The first one would cancel out the 9. You'd have 3.94x plus the x would cancel out on the second one, giving you 9 times 3.94. And on the other side, if you multiplied by 9.34x, oops, that's 3. I've transposed the numbers. Poopy. There we go. Fix that. Sorry. Times 3.94. It's Friday, you know. Sorry. That 3.94 cancels, and you get 9x. Okay, so let's subtract 3.94x, and someone multiply that out for me so I don't have to think so hard. 35.46 here. Okay, and then 9x minus 3.94x, that's going to be 6. What? Is this right? 5 point, no, it's not. 5.06. Okay, good. Thank you. And then you know what to do next. Divide 35.46 by 5.06, and you're going to get about 7 hours. How close is it to 7? Is it really, really close? All right. Thank you.